Once again, I welcome students to my video lectures on signals and system. This is preliminary class number 5. In this class, I will explain what is known as a gate function. Gate, nothing to do with gate examination. Gate function. So students should have a knowledge of gate function, because in signals and system, after first chapter, they will understand the physical meaning of convolution integral. While doing problems on convolution integral, they are supposed to know the utility of this function called gate function. So gate function is a very useful function used in signals and system, and I will concentrate on this gate function, and I will sketch gate function at the end of the class. So this gate function application is graphical erasing. Graphical erasing. You know what is erasing? Erasing means to rub, to remove. So here, if I have an eraser here, I can rub any writing. I can make the writing to vanish using this eraser. So graphically, mathematically, if you have to erase any portion of the graph, you require a function called gate function. So gate function is used for graphical erasing. Now I will give introduction to gate function. So here in this, I have shown a diagram of a house encircled by compound wall with gate. So this is house, compound, and for this compound, for a narrow portion, there is a gate. What is the importance of gate? So for people to enter the house, is it not? Decent people. So decent people will enter this house through opening this gate. Let us not bother about indecent people who enter house on jumping the compound. So gate. So here also the gate means meaning. Here it is a narrow passage to the house from outside. So see, you bear this in mind, this gate, a compound gate. Now I will explain what is a gate function. A gate function is a rectangular pulse. So what is a gate function? A gate function is a rectangular pulse. Rectangular pulse of unit height. Rectangular pulse of unit height and of flexible width. Flexible width. Flexible width. Rectangular pulse of unit height and of flexible width. Now the question arises, why it is of unit height? Because this function, gate function, is to be multiplied with other functions, and it should not alter its value. That is why we take unit height. So you have come across in digital electronics. So on multiplying x with 1, is there any change in the value of x? No. X into 1. So logic x multiplied with 100. Here it is x. So the value is unaltered. Is it not? So 1 is called as identity element. So here also, gate, it is a rectangular pulse of unit height and of flexible width. Now I will sketch the gate function. So this is also a gate. This is a gate function. Height has to be 1. Now this is of width. This is called as width. This is called as width. The width of the pulse. It can be like this also. So now here it is a narrow width, narrow pulse, but still the height is 1. Now this is also another example of, now it has been expanded, but still its height is 1. This is also a gate function. This is also a gate function. This is also a gate function of different width. So what is gate function? A gate function is a rectangular pulse of unit height and of flexible width. So in problems, we used to vary the width of the pulse. It all depends on the problem. So in the next class, I will take up how to do graphical erasing. I will explain this point. Graphical erasing. I will give just an introduction to graphical erasing by giving this example. Okay? I will give this example. Suppose you are given a graph like this. You are given a graph like this. For example, take a straight line. Take a straight line extending from minus infinity to plus infinity. So take a straight line passing through the origin. So varying from minus infinity to plus infinity. You want to erase this portion. That is, for negative values of t, you want to erase this. After erasing, how the waveform looks? The waveform looks like this, because this has been erased. Erased means 0. So after erasing, it looks like this. You can do this erasing with gate function. Or I will give one more example. One more example. Once again, I will take a straight line like this. I want to erase this portion. After erasing this portion, now the waveform looks like this. Now this previously it was extending like this. After it is erased, its value becomes 0. Now only negative, for negative values of t, the function remains. So changeover from this figure to this figure is possible using a function called gate function. So in the next class, I will explain how to write gate function and how to do what is known as graphical erasing.